Welcome. This is Odum Maths. Today I want us to continue our discussion on solving example on bearings. Okay, so we are given this example, that is a ship sails from Port R on a bearing of 65 degrees to Port S, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from Port S to Port Q, a distance of 80 kilometers. Find, correct to one decimal place, the distance between R and Q. The bearing of Q from R. So let's keep notes of these. Now, from Port R to Port S, 65. So let me write those things here. So R to S, 65 degrees, then 54 kilometers. Then again, it then sails on a bearing of 155 from S to Q. So S to Q is also 155 degrees, then 80 kilometers. 80 kilometers. Okay. So we are told to find the distance between R and Q, and then the bearing of Q from R. Okay. So now let's get the diagram drawn. So from R to S, 65 degrees on a bearing of 65 degrees from R to S, and then the distance 54 kilometers. So before we draw, let's look at this. 65 will fall on the first quadrant, from the geographic north to where east is. Okay, so let me put this diagram here. So this is 65, and then so R to S, 65, 065 degrees. We are moving this direction. Then from S to Q is 155, and 155 will fall here. So 155, 80 kilometers. Please, like I said, so this is 54 kilometers. The length here, the line should be shorter than the one we are going to draw, so that we'll get the exact answer or angle. So 155, 80 kilometers. So let that one to come here. So this is Q. Then from here to here is 155 degrees. So we are finding the distance between R and Q. So R and Q, let me join them. Okay. So let's look at this. From this point to this point is 90. So we added 65 to this to get 155. So it means that this place will be 25, or 25 plus this will give us 180. Okay, so this small angle here is 25 degrees. And let's look at this. If this is 65, then its alternate is this one. So here also is 65 degrees. So when you add the two, we are going to get the 90 degrees. Okay, now this side is 80 kilometers. Okay, so we are to find this one. So since this is a right angle triangle, we can use the Pythagoras theorem, or let me change and then use another method. Okay, so because we are known to the Pythagoras theorem, I want to use another method in the sense that when we get where the angles are more than, or where we have one interior angle more than 90, then this is how we are going to go about solving this. Okay, I'm going to use the cosine rule. Okay, so for the cosine rule, let me call this side x. So x squared is equal to 54 squared plus 80 squared minus 2 into brackets 54 times 80 cos, and x faces this angle, so cos 90 degrees. Okay, now because this side is cos 90 degrees will give us 0. So it means that from here to here is 0. So I can ignore this and then look at x squared being equal to 54 squared plus 80 squared. Okay, so x squared becomes 2916 plus, okay, and then 80 squared is 6400. Okay, so when you add the two, we are going to get 9316. Okay, so x squared is going to be 9316. So we put square roots on them, and then x is going to be 96.52. The question says to one decimal place. So x is equal to 96.5 kilometers. Okay, so this is the distance between R and then Q. So let's look at the bearing. So the second one, the bearing of Q from R. I'm using the cosine rule to get the angle. Now, 80 squared is equal to x squared plus 54 squared minus 2 into brackets x times 54 cos theta, because theta faces 80. So cos theta. Okay, we know x to be 96 points. Please, we don't use the final one, we use this one. Okay, so 80 squared is 6400 equals x squared. So that is going to be 96.52 squared plus 54 squared minus 2 into brackets 96.52 times 54 cos theta. Okay, so 6400 is equal to 96.52 squared is this one. So that is 9316 plus 54 squared. We had 2916 minus 2 into brackets. Let's look at 54 times this one. So this is also 5212.08 cos theta. Okay, now we add this. So 6400 equals, so 9316 plus 2916. This is going to give us 12232 minus, now 2 times of this, 10,424.16, still cos theta. Okay, so we need to move this here and send this there. So that is going to give us 10,422.16 cos theta equals 12232 minus 6400. Okay, so this is going to give us 5,832. So 10,424.16 cos theta is equal to this. So we need to divide both sides by 10,424.16. Then here to 10,424.16. Okay, so here cos theta is equal to, when you divide this, that is going to give us 0.5595. So to 4 decimal places. So we find cos inverse of this. Theta is equal to cos inverse of 0.5595, and theta becomes 55.980. Okay, so we can round this to 1 decimal place, though this is not the final answer. So theta is approximately to 1 decimal place, that is 1, so 56 degrees. So now let's go to the question itself. So we've gotten the angle, the small angle here, to be equal to 56 degrees. Okay, now the bearing of Q from R, becomes 65 plus 56. The bearing of Q from R is 65 plus 56. That is 121 degrees. Okay, let's look at one more example. Cyclists start from point X and rides 3 kilometers due west to point Y. At Y, he changes direction and rides 5 kilometers northwest to point Z. How far is he from the starting point? Correct to the nearest kilometer. I find the bearing of Z from X. Okay, so let's draw the diagram first before we start. Now, look at this. 3 kilometers due west. So means X is on the eastern side. So let me bring the first point here. So that is X. Now, due west 3 kilometers. So due west, I'm moving towards this direction. 3 kilometers. So let me end here. 3 kilometers to point Y. So this is point Y. At Y, he changes direction and rides 5 kilometers northwest. So northwest. So this is west. Now northwest means we are going to divide this angle into 2. So 45, 45. So this is where Z is. Okay. And then we are told to find how far is he from the start. This is the starting point and this is the ending point. So let me join these 2 points together. Okay. And then let's look at this. This angle here is 45 degrees. So, and this is also 90. So the 2 will give us 135 degrees. Okay. We don't know this angle. So let me call it theta. Okay. Now, the second answer is find the bearing of Z from X. So the bearing of Z from X. So we add this one to theta before we get that of the bearing of Z from X. Okay. So let's get this distance because how far is it from the starting point? So that is from here to here. So let me call the distance here X. Okay. So since I know this angle and which faces X, I can use the cosine rule. X squared is equal to 5 squared plus 3 squared minus 2 into brackets 5 times 3 cos 135 degrees. This is going to give me x squared is equal to 25 plus 9 minus, this is going to be 15 times 2 minus 30 cos 135 degrees. Okay, so let me add these two. So x squared becomes, this is going to give me 34. 34 minus 30 cos 135 degrees. Okay, so I need to do justice with this one and subtract it from 34. So x squared becomes 34, then this is negative 30 cos, so that is going to give us plus 15 root 2. So x squared becomes, this is going to give us 55.2132 to 4 decimal places. Now we put square roots on both sides. So x becomes 7.430, so 6, 1, 2, 3, so 6 kilometers, but to the nearest kilometer. So to the nearest kilometer means x is equal to 7 kilometers. Okay, to the nearest, because this is closer to 7 than 8. Okay. Now we are left with finding the bearing. Okay, and in that case too, what we have to do is we look at this angle which faces this side. So we can use the sine rule if possible. We can use the sine rule because sine theta over this side should be equal to sine 135 over this side, and we'll get the answer. So let's use the sine rule instead. So sine theta over the side it faces over 5 should be equal to sine 135 over x, and x is known to be this. So cross multiplication, this is x sine theta, and which is equal to 5 sine 135 degrees. So Then you divide both sides by x. So let me manage the side. Okay, so here x will take care of this x, and then we have sine theta being equal to 5 sine 135 over, and x is this figure, so which is 7.4306. So sine theta becomes, so sine theta is 0.47580. So 1, 2, 3, 4. Okay, so 5, 8. Then theta is going to be sine inverse of 0.4758. So theta becomes 28.4119 degrees. Okay, so we need to add this to 270. So now we've gotten theta to be 28.4119 degrees. So we need to add, because the bearing of z from x, we move from here out to this point. So we are going to add these angles to theta. And this is going to give us, that is 270 degrees. So the bearing of z from x will be 28.4119 degrees plus 270 degrees. And that is going to give us 298.4119 degrees. And we can make it to the nearest degree. So that is equal to the nearest degree, that is equal to 298 degrees. So the bearing of z from x is 298 degrees. Thanks for watching. We'll meet in the next lesson. Please don't forget to subscribe, like and share this channel. The name has always been Odum Maths. Bye.